Okay, so for the last part, we're going to bring back in some of the stuff we did at the beginning of the unit where you had to draw right triangles. So it's kind of cool to see how this stuff all goes. So for the first one, we're looking at cosine of arctangent x. So these are still composition functions, so there's still a function inside of a function. So we're going to start with the inside part. So we're going to start with arctangent x. So if we want to rewrite it, so this is the same thing as saying tangents of theta is equal to the inside part, which is x. Okay. Now we're not using the unit circle, so you don't have to worry about those principal values or anything, but you do have to rewrite. So we know that tangent, and we're going to be doing triangles, so we're thinking about SOHCAHTOA. Since we're not using the unit circle. So tangent we know is this TOA, which is O over A. So we know tangent is O over A, and we know that's equal to x. So that I can write it as a fraction, this is the same thing as saying x over 1. So that tells me that my opposite part is x and my adjacent part is 1. So I'm going to draw a triangle. You can draw your right triangle however you want. Just label your angle so you know where everything's going to go. So this would be my opposite, this would be my adjacent, this would be my hypotenuse according to my angle. So we said opposite is x, adjacent is 1. Okay? So before I do the outside part, I'm going to go ahead and figure out what the hypotenuse is. So we're going to use Pythagorean theorem. So my two outside parts, we have x squared plus 1 squared is equal to my hypotenuse squared. So this is going to be x squared plus 1 equals h squared. So the square root of x squared plus 1 is going to be my hypotenuse. So I'm going to write that over here. Okay. So the last part now that we have to worry about is this cosine part. Okay, we've already took the inside and made a triangle. So we know cosine, according to SOHCAHTOA, is A over H. So now you're just going to use your diagram. So A for my triangle is 1. H for my triangle is the square root of x squared plus 1. And that is going to be your final answer for that part. Alright, so then if we take a look at number 2, same kind of thing. So cotangent of cosine of negative 1 of x. So guys, if you're wondering like how you're going to know that you're supposed to draw a triangle, if you notice this does not have any radian measurements here or any numbers, it just has the variable x. So that's how you know you're going to use your triangles. So we are going to use SOHCAHTOA. Okay. Alright, so we're going to start with the inside because it's composition. That's an inverse function, so we want to rewrite it as cosine theta equals x. We know from SOHCAHTOA cosine is A over H. So this is A over H, and because it's just x, I'm going to write it x over 1. So we know that adjacent part is x, the hypotenuse is 1. So I'm going to draw a triangle. I always just draw my triangles the same. This is my opposite, my adjacent, and my hypotenuse. We know that adjacent is x, hypotenuse is 1. So I'm going to go ahead and figure out what the opposite side is going to be. So I'm going to put a fancy little O here, so I'm going to do like O squared plus A squared, which is x squared, is equal to my hypotenuse squared. Okay, I want to solve for this O, which is opposite. So I'm going to subtract over my x squared, and then I'm going to take the square root. So my opposite side is the square root of 1 minus x squared. So now if we take a look at the outside part that we haven't finished, so cotangent. Now we know cotangent goes with tangent, but it's the reciprocal of it. So instead of O over A, it's A over O. Now for my diagram, we know A is x. And we know O is the square root of 1 minus x squared. So this is going to be my answer. Okay, and then for the last one, 3. So once again, this has a variable, it has that x. So we're going to be using a right triangle instead of unit circles. So we're going to use SOHCAHTOA. Okay, so we're going to start with the inside part. This is inverse, so we want to rewrite it as cosine theta equals 3x. We know from SOHCAHTOA that cosine is a over h. So that's going to be 3x, and I'm going to put it over 1. So we know that a has to be 3x and the h has to be 1. So I'm going to draw a triangle so I can label this. Opposite, adjacent, hypotenuse. We know a is 3x and we know h is 1. So once again, I need to solve for this opposite part. So I'm going to make a little fancy O again. Plus my adjacent, which is 3x squared, equals 1 squared. Now be a little careful in this. That 3 squared, the 3 has to get squared and the x, so that's 9x squared equals 1. And I'm going to subtract over my 9x squared. And then I'm going to take the square root. So my opposite is the square root of 1 minus 9x squared. Okay, so that took care of the inside part. Now we're looking at the outside part, which is sine. We know sine from SOHCAHTOA is O over H. So O for my diagram is the square root of 1 minus 9x squared. And H is 1. So you can leave it like that, or you can just do the square root of 1 minus 9x squared. And that will give us our final